Welcome to This Explainer. Today, we're skipping the basic definitions and jumping straight into the architectural evolution of the Internet of Things. We're going to trace its journey from those really early conceptual roots all the way to the massive data-driven engine that's absolutely powering modern enterprise strategy. Now, for those of us tracking infrastructure and digital transformation, you know it's incredibly easy to get completely lost in the noise of new hardware releases and hyper-specific use cases, right? But to truly grasp where this technology is heading, we need to take a step back and look at the macro evolution of connected devices. So we're going to unpack exactly how this transformation happened, the major technological milestones that made it a reality, and most importantly, what this interconnected architecture actually means for the future of global industries. Okay, let's dive into this. 1999. To genuinely wrap our heads around the massive scale of modern connected infrastructure, we have to rewind to the tech landscape of the late 90s. Picture it, the era of screeching dial-up internet, the absolute peak of the dot-com boom. It was a time when the mere idea of machines autonomously talking to each other sounded like pure science fiction. Back then, network bandwidth was heavily restricted, data storage was unbelievably expensive, and enterprise software, well, it was mostly locked away in its own little silos. Now, telemetry did exist, sure, but it was hardwired, localized, and, let's be honest, incredibly clunky. And yet, right in the middle of all those limitations, the foundational seed for what would become a multi-trillion-dollar ecosystem was planted. Visionaries were just waking up to the idea that the internet could be used for way more than just human-to-human chats or basic web browsing. The wild idea that physical everyday objects could be nodes on a network was literally just taking root.
And that massive foundational shift, it traces directly back to a guy named Kevin Ashton. To understand the origins of this whole movement, we have to look at the very practical and honestly kind of mundane problem Ashton was trying to solve. He was working at Procter & Gamble at the time, and he was tasked with fixing a highly unglamorous but financially massive headache: supply chain inefficiencies and the constant, annoying problem of out-of-stock cosmetics on retail shelves. He realized the core bottleneck was us, human data entry. Computers only knew what human beings told them, which meant the data was slow, filled with errors, and totally limited by human attention spans. Ashton had this light bulb moment. If computers knew everything there was to know about things, gathering data entirely on their own without us interfering, we could track and count everything. It would heavily reduce waste, loss, and cost. So he wanted to pitch this innovative idea of sticking radio frequency identification, or RFID tags, on products to track them seamlessly. But to sell it, he needed a catchy title for his presentation. And boom, he coined the term Internet of Things. It was a brilliantly simple phrase that perfectly captured the vision of giving physical objects internet connectivity. And this brilliantly illustrates the staggering paradigm shift we've experienced over the last couple of decades. The journey from tracking a single tube of lipstick in a warehouse with a passive, basic RFID tag to the wildly complex ecosystems we rely on today is frankly an architectural revolution. We've totally transitioned from those isolated passive sensors to highly complex, globally interconnected systems that run on edge computing, lightning-fast 5G networks, and artificial intelligence. I mean, think about it. In the early days, the biggest challenge was literally just getting a device to emit a simple signal. Today, no way. Today, we're dealing with autonomous transport fleets talking to each other in real time to optimize global shipping logistics. We have industrial manufacturing robotics making millisecond-level tweaks based on environmental data. We even have municipal smart grids balancing power across entire cities to stop blackouts before they happen. It is a massive evolutionary leap from simple location tracking to complex predictive intelligence that actually learns and adapts on the fly.
So, to understand the mechanics of how this predictive intelligence operates out there in the real world, let's break the modern enterprise application down into 3 crucial interconnected steps. First up, we look at the players in the industries. These are the forward-thinking organizations completely ripping out and overhauling their legacy systems. They are investing heavy capital to upgrade hardware so that every critical piece of infrastructure, from factory floor motors right down to shipping containers, is packed with sophisticated telemetry. Step 2 is how they actually use this technology. Because look, it isn't just about dumping raw data into a centralized server anymore. It's all about edge analytics. By processing data right at the edge of the network, closer to the actual source, companies drastically cut down on latency, save on bandwidth, and make instantaneous decisions possible. And finally, step 3, harnessing the power. This is where the real magic happens. Organizations take all that localized data processing and feed it into sophisticated machine learning algorithms. They completely shift their operational models from reactive troubleshooting, putting out fires, to proactive predictive management. So the crucial point here, the big so what, is the ultimate tangible payoff of all that predictive management, and that is unprecedented business opportunities. When organizations successfully master these interconnected systems, the financial and operational rewards are absolutely massive, and they totally redefine a company's market position. We are not just talking about incremental efficiency here. We are talking about fundamentally altering business models. It's a real game changer. Take predictive maintenance in heavy manufacturing, for instance. Instead of waiting for a critical multi-million-dollar turbine to break down and completely halt production for weeks, connected sensors can spot microscopic vibration or temperature anomalies and automatically schedule a targeted repair during planned downtime. The cost savings? Absolutely astronomical. Or look at smart agriculture. Farmers are using interconnected soil sensors, drone imagery, and real-time weather data to optimize their water and fertilizer use down to the exact square meter. It drastically boosts crop yields while heavily conserving resources. These are the kinds of paradigm-shifting opportunities that are driving this relentless expansion of connected ecosystems. When we look back at the monumental leap from those early 1999 RFID experiments to the predictive, self-optimizing global networks of today, it really forces us to take a hard look at our own strategic roadmaps. The architecture has matured, the technological barriers to entry have absolutely plummeted, and the competitive gap between the companies leveraging this infrastructure and those lagging behind is widening exponentially. So, the question is, how will your industry harness this profound technological shift? Will you use it to optimize logistics, revolutionize your product life cycles, or maybe even create entirely new service models fueled by real-time data? Honestly, that is the single most critical question enterprise leaders are facing today. Thank you so much for joining me on this explainer. I hope this deep dive leaves you fully equipped to analyze, understand, and ultimately optimize your very own connected ecosystem.